Okay, so let's dive in. Imagine this for a second. You're building a web app, right? And you're writing your front-end code in Ruby.
Just like your backend code.
Exactly. And get this, the Ruby objects you have in the browser, they're talking directly to the Ruby objects on your server, like over the network, but as if they were just right there.
Yeah, no messing around with REST APIs, no endless JSON encoding and decoding, just objects calling methods on other objects.
It sounds almost too good to be true, doesn't it?
Yeah.
Like science fiction for web dev.
Well, it's not quite science fiction anymore. Today we're going deep into some really fascinating explorations happening right now to try and make this a practical reality specifically for Ruby.
We're looking at a talk from RubyKaigi, presented by Yu Chan and Red Sun, and their whole focus was on getting dRuby, that's Ruby's own distributed object system, to actually work inside a web browser.
Right, so our mission, if you will, for this deep dive is to unpack how they're actually doing it, what technologies are they using. We'll definitely talk about RubyWasm, which is a pretty hot topic.
Yeah, definitely.
And we'll look at the demos they showed off, which were quite cool, and also, maybe most importantly, the big challenges they've run into, because it's definitely not straightforward.
Think of this as your shortcut to understanding what's really involved in trying to bring genuine WebSocket programming, that kind of distributed feel, into the browser world.
And it's worth mentioning, this isn't totally out of the blue for Yu Chan. The talk referenced his previous work. He's been poking at Ruby in the browser for years using Opal before.
Oh, right. Opal, another Ruby to JavaScript approach.
Exactly. He was doing virtual DOM stuff with it way back in 2015, then isomorphic programming in 2016, and he even tried CRuby on the browser with Opal back in 2017.
Okay, so this idea has history.
It does, but this latest push, the one from the talk, is really centered on using RubyWasm as the base. It's kind of the next evolution, leveraging this newer tech.
Okay, so before we get into their specific approaches, maybe we should quickly cover the key building blocks here, just so everyone's on the same page.
Good idea. First up, there's WASM itself, WebAssembly.
Right, the low-level bytecode for the web.
Pretty much. Think of it like machine code that browsers can run really fast inside a virtual machine. It's usually compiled from languages like C or C++A or Rust.
Got it. And then specifically RubyWasm.
So RubyWasm is exactly what it sounds like. It's the standard C implementation of CRuby, but compiled to WASM.
Ah, okay. So it lets you run actual Ruby code in the browser, not some Ruby-like language.
Precisely. Actual Ruby executing in the browser's WASM VM. And a fun little side note from the talk they mentioned, it was largely made by a scientist at home.
Hey, I like that. Shows the passion behind it.
Definitely. Okay, so that's WASM and RubyWasm. The third key piece, really central to this whole discussion, is dRuby, distributed Ruby.
Right, which is built into Ruby, isn't it?
Yeah, it's part of the standard library. It's Ruby's way of letting objects in different Ruby processes or different Ruby virtual machines talk to each other.
How does that work, basically?
Well, the core idea is you have a kind of placeholder, a stub object, in one place, say, your browser. When you call a method on that stub, dRuby takes care of sending that method call across the network to the real object, which might be living on your server. The method actually runs on the server. That's the remote procedure call, or RPC part.
Okay, so the call happens remotely. What about the data, the results?
Yeah, so results, or even other Ruby objects, can be sent back and forth. dRuby uses Ruby's standard serialization system, Marshall. If an object can be marshaled, it can basically be packaged up and sent over the wire between the two Ruby environments.
Okay, so RubyWasm lets Ruby run in the browser, and dRuby lets Ruby objects talk across processes. Combining them seems, well, powerful. But what's the big win here? Why bother?
It's really about changing the development paradigm for web apps. Think about the typical way. You set up API endpoints on the server, write controllers, figure out how to serialize your Ruby objects into JSON. Then you write JavaScript on the client to fetch that JSON, parse it, maybe turn it back into some kind of JavaScript object.
It's a lot of steps, a lot of translation.
Exactly. It's all this glue code, this impedance mismatch between your Ruby backend and your JavaScript frontend. The dRuby vision, powered by RubyWasm, is way simpler.
How so?
The server just defines its logic using regular Ruby objects, and the Ruby code running in the browser, thanks to WASM, just calls methods on those remote objects like they were local.
So it collapses that whole API layer.
Pretty much. It aims for direct object-to-object communication. It's less about just simplifying API calls and more about changing the whole worldview, making it feel like a cohesive Ruby environment end-to-end.
And the talk mentioned another benefit, especially for apps where multiple people are interacting.
Oh, yeah, that's a key point. Because
Yeah.
you're dealing with actual Ruby objects on the server, you could have multiple browsers all interacting with the same object instance on the server.
Ah, like for a shared document or something?
Exactly. Imagine a collaborative editor or maybe like a shared dashboard. Instead of building complex logic to push updates or sync state using WebSockets and custom messages, maybe multiple browser clients could just call methods on a shared server-side Ruby object via dRuby.
And that object manages its own state.
Right. The state management becomes much more centralized and potentially simpler compared to layering it on top of, say, a REST architecture.
That does make a lot of sense. It really extends that object-oriented way of thinking across the network. So, okay, that's the why. How did Yu-Chan and Red Sun actually try to build this? What were their approaches?
So they presented two approaches. Different, but kind of aiming at the same goal and definitely related. Yu Chan's work was more focused on implementing the dRuby protocol itself on top of RubyWasm. He actually created two new Ruby gems to do this.
All right, tell me about those.
So first, on the server side, there's a gem called dRuby WebSocket. Its job is to implement the dRuby protocol, but instead of using standard TCP sockets, it uses WebSockets for the transport layer.
Makes sense for the browser.
Yeah. It uses another library called WebSocket under the hood, and it can run either as a standalone server or, quite neatly, as rack middleware, so you can plug it into your existing web apps.
Okay, server-side handled. What about the client, the browser side?
That's the second gem, WASM. This one provides the dRuby client implementation that runs inside the RubyWasm environment in the browser.
Got it.
Now here's a slightly quirky detail. This client-side gem, YSM also includes a dRuby server implementation.
Hang on. The client gem includes a server. Why would the browser need to act as a dRuby server?
Yeah, good question. It's all about callbacks.
Callbacks.
Think about it. In Ruby, it's possible for the server object to call methods back on objects that originated from the client. Like maybe you pass a Ruby block or some kind of handler object from the browser to the server.
Okay.
Later on, the server might need to invoke a method on that handler object that's now conceptually living back in the browser's RubyWasm environment. To receive those incoming calls from the server, the browser side needs to be listening, acting like a server.
Ah, okay, that clicks now. It needs to listen for those return calls. So Yu-Chan basically built the dRuby over WebSockets bridge for both ends. What was Red Sun's angle then?
Red Sun took a slightly different, maybe lower-level approach. His focus was more on abstracting the WebSocket communication itself, trying to make it feel like standard, synchronous RubySocket programming, even when running in the browser via WASM.
Okay, abstracting the transport layer?
Exactly. He built a library called WANZ.
WANZ, I remember seeing that. He said it stood for Web and Socket, but also Magic Wand.
Yeah, precisely. Because the goal is kind of like a magic trick. Hide the messy asynchronous reality of browser WebSockets and let the Ruby developer just write code using familiar synchronous style methods like puts and gets.
Like you would with Ruby's normal TCP socket class.
Exactly like that.
Yeah.
The big aim for WANZ is code portability. You write your socket using Ruby code once, and ideally it just works whether you run it in regular CRuby or compile it to WASM for the browser.
Okay, so let me see if I've got this straight. Yu-Chan built the actual dRuby protocol layer to work over WebSockets. And Red Sun built an abstraction, 1AZ, to make WebSockets themselves behave like standard Ruby sockets.
Yeah.
Which something like Yu-Chan's dRuby implementation, or really any Ruby code wanting to do socket-like things in the browser, could potentially use.
That's a really good way to put it, yeah. Red Sun is providing that sort of synchronous illusion over the browser's fundamentally asynchronous nature.
Very interesting. Did they show this stuff working? Were there demos?
Oh yeah, they did. They had a couple of pretty convincing examples. Yu-Chan showed a shared object thing.
What did it do?
He had two browser windows open. In one, he incremented a counter value, like clicking a button, and instantly the updated value appeared in the other browser window.
Ah, showing that shared state via the server-side dRuby object.
Exactly. Clear demonstration of multiple clients talking to the same backend object. He also mentioned JVA2, which is his own presentation tool.
Right, a slide tool. Why is dRuby relevant there?
Well, the example they gave was pretty illustrative. Markdown parsing. Say your slides are written in Markdown. You could bundle a whole Ruby Markdown parsing gem into your RubyWasm payload that goes to the browser.
But those gems can be big, right? Bloat the download.
They can be, yeah. So the dRuby alternative is keep the client light. When you need to parse Markdown, the client just makes a quick dRuby call to the server, sends the Markdown text,
The server parses it using its potentially beefier resources and installed gems.
and sends the resulting HTML back to the client. It's a nice way to offload work and keep the client footprint smaller.
Yeah, that offers some nice architectural choices. Okay, but you mentioned hurdles, challenges. This couldn't have all been smooth sailing. What were the big sticking points?
Right, this is where things get technically quite deep and frankly a bit tricky. The biggest challenge they both really hammered home is this fundamental mismatch between how Ruby normally expects things to work synchronously and how browsers work asynchronously, event-driven.
You mean like in Ruby, if you call socket.gets, your code just stops and waits for data to arrive?
Exactly, it blocks. But in the browser, when you use WebSockets, you don't block. You send a request, and you attach an event handler, like an on-message callback, that fires later when data comes back.
So how does that clash with dRuby running in WASM?
Well, when your Ruby code running in WASM makes a dRuby call, which goes over a WebSocket, that network operation is inherently asynchronous from the browser's point of view. In JavaScript, you'd normally get back a promise and use await.
Right.
The challenge is, how do you make that asynchronous operation look and feel like a simple blocking synchronous call to the Ruby code inside WASM? So the Ruby code can just wait for the result without needing complex async await patterns within the Ruby code itself.
And they mentioned something called asyntify in RubyWasm. Helps with this, but it's complicated.
Yes, asyntify is this sort of low-level magic within the WASM compilation process that allows linear code, like compiled Ruby, to essentially pause itself during an async operation and then resume later when the result is ready. But actually understanding how to use it correctly, especially when dealing with JavaScript promises, and crucially, those callbacks from the server back into the WASM environment, they made it clear it was really hard to wrap your head around.
Getting the WASM world and the JavaScript event loop world to play nice sounds non-trivial.
Definitely. They even showed a snippet of code, I think it was in an event handler for a server callback, that needed these explicit fiber transfer calls. That's pretty low-level Ruby concurrency stuff, which just highlights that the bridge isn't entirely seamless out of the box yet.
So RubyWasm lets Ruby run, but making it interact idiomatically with the browser's async nature takes extra work.
That sums it up well. There's an abstraction layer needed.
Okay, so facing these difficulties, what solutions did they actually implement? How did they make it work, despite the sync-async clash?
Well, they each tackled it from their own angle, naturally. For Yuchan's WASM dRuby gem, the dRuby implementation itself has logic built in to handle the fact that the underlying WebSocket calls return promises, sort of integrates the await part internally.
So it manages the async underneath the dRuby call.
Kind of, yeah. It papers over some of it for the user of the dRuby client.
And what about Red Sun's WANZ, the magic wand? How did he make async WebSockets look like synchronous gets and puts?
His approach is pretty ingenious, actually. He leverages a specific feature of RubyWasm's JavaScript integration, something called a promise scheduler, and combines it with a concept very similar to Ruby's built-in queue class. He called his version Q.
Okay, Q. How does that help?
So imagine your Ruby code wants to read data from the socket, which is secretly a WebSocket. It calls a method like queue.pop.
Which, in normal Ruby, would block if the queue is empty, right?
Exactly. So is QPop does something clever. It creates a JavaScript promise that represents the data that will eventually arrive, and then it uses that RubyWasm promise scheduler to basically pause the Ruby execution and hand control back to the browser's event loop. The Ruby code just sits there looking like it's blocked.
Waiting for the promise.
Right. Then, when the browser's actual asynchronous WebSocket on-message handler finally gets some data from the server, that JavaScript handler takes the data and effectively pushes it onto Red Sun's conceptual queue, like calling queue push data. Pushing the data resolves the promise that the Ruby code was waiting on.
And that wakes the Ruby code back up.
Precisely.
Yeah.
The promise scheduler sees the promise as resolved and resumes the Ruby fiber that was paused at the queue top, handing it the data.
Wow. Okay, that does sound like a magic wand. It completely hides the asynchronous callback mechanism behind a familiar blocking queue interface.
It's a really neat abstraction. It directly achieves that WANZ goal, right? Synchronous-looking Ruby socket code run it in the browser. He also mentioned that this made testing much cleaner. He could use standard RSpec to test the core synchronous logic of his library just using regular CRuby. Then for the browser-specific async bridging part, he could use tools like Node.js and something called NodeWaji, which runs WASM within Node, to test that interaction, treating the whole setup like socket programming in the browser.
That's pretty cool. Okay, so let's pull back a bit. We've gone into RubyWasm, dRuby, async challenges.
Yeah.
Why should you, listening right now, really care about all this? What's the takeaway?
Well, I think it matters because this isn't just, a theoretical exercise. These folks are building foundational tools that could genuinely change how you build interactive web applications if you like Ruby. They're trying to break us out of the sometimes rigid structure of REST APIs and constant JSON juggling. Imagine being able to use Ruby's powerful object model, which many find intuitive, directly across that client-server boundary.
Building complex, maybe real-time features, but just having objects talk to other objects.
Exactly. Instead of spending half your time designing API endpoints and serialization formats, you could potentially focus more on the core logic of your application, expressed in a consistent Ruby style everywhere.
It really feels like it could boost productivity and maybe even allow for more expressive code for Rubyists doing web work. Less plumbing, more building.
That's the dream, I think. Bringing Ruby's strengths, its developer focus, its object model into this increasingly important browser environment.
Which kind of leads us to a final thought to chew on from this deep dive. We've seen how Yuchan and Red Sun are essentially performing this technical magic trick with tools like WANZ.
Yeah, making synchronous Ruby code feel natural in the asynchronous browser world.
So the question to ponder is, if this kind of deep abstraction, this blend of Ruby philosophy and WebAssembly's cross-environment power, can bridge this gap, what other magic could it unlock? What other seemingly incompatible programming models or environments could we make work together seamlessly in the future?
That's a fascinating question. The potential to take complex underlying systems and present simple, familiar interfaces, that's always powerful.
It really is. Definitely an area to keep watching.